In under 2 seconds, a family saloon leaves every conventional sports car in its dust. Not a laboratory prototype, not a motor show concept, a car you can buy today. That result alone would be enough to shake the industry. But what lies behind that number is what truly changes everything. And most competitors still haven't grasped the scale of the problem. A new motor wrapped in carbon fibre. A rotational speed exceeding 20,000 revolutions per minute. An acceleration that until recently only existed in million-dollar hypercars. Tesla has just redefined what an electric motor can do. And it's done so in such a radical way that rivals must ask themselves, what exactly are we competing against? To understand why this motor matters, we need to go back in time. In 2003, when Tesla Motors was founded, the automotive industry viewed the project as a joke. The electric cars of the era looked like golf buggies with windows. The idea that an electric car could compete in performance and driving pleasure was completely dismissed by industry experts. When Elon Musk entered the picture, he brought a different vision. An electric car needed to be the most beautiful, fastest, and most thrilling thing you'd ever sat in. In 2008, the first Roadster proved one simple but revolutionary thing. An electric motor could produce real power. Then came the Model S, the Model X, the Model 3, the Model Y, and the Cybertruck. Each launch triggered a chain reaction. Ford, GM, Volkswagen, Hyundai, and Kia rushed into the electric segment. Many experts said Tesla had reached its peak. They were wrong. Because whilst everyone was trying to catch up with what the company had already achieved, it was quietly preparing the next leap. The plaid motor with carbon fibre sleeve. To understand why this motor matters, we need to look at the rotor, the rotating part responsible for converting electrical energy into movement. In most motors today, the rotor is made from copper and steel alloys. These materials have a clear physical limit. As rotational speed increases, centrifugal force grows exponentially. The material deforms, more heat is generated, and the system loses efficiency at precisely the moment you need it most. Tesla solved this by wrapping the rotor in carbon fibre, the same material used in Formula One cars and aircraft. Carbon fibre is lighter, more rigid, and far better at withstanding tensile forces at high speed. The carbon layer creates compressive pressure that keeps the structure stable even at extremely high rotational speeds. The result? Tesla's rotor exceeds 20,000 revolutions per minute, directly generating the power you feel at the wheel. This is why the Model S Plaid goes from 0 to 100 km per hour in under 2 seconds, a figure that until recently only existed in million-dollar hypercars. But speed is only part of the story. Because the rotor is lighter, the motor requires less energy to spin. With the same amount of electricity in the battery, the car travels further. The cooling system works less hard. Battery life is extended. A more efficient motor, a more durable battery, greater range, and lower running costs, all working together. There is also thermal stability. The carbon sleeve does not expand in the same way as metal. It maintains consistent compressive pressure regardless of temperature variations, keeping the rotor stable in all conditions. This is not merely the fastest motor Tesla has ever built, it is also the most durable, the most stable, and the most efficient. Now comes the part that is truly surprising. Wrapping carbon fibre around a metal rotor sounds straightforward in theory. In practice, it is one of the most difficult engineering challenges Tesla has ever faced. Carbon fibre and metal have different thermal expansion coefficients. If you simply wrap the carbon around the rotor without extremely precise calculations, when the temperature rises, the layer can come loose, crack, or cause severe imbalance at 20,000 revolutions per minute. To solve this, Tesla built a robotic system controlled by artificial intelligence, capable of applying the carbon layer with micrometer-level precision, 1/1000th of a millimeter. The system simultaneously controls fiber tension, ambient temperature, process speed, and application angle. Each rotor is checked with laser sensors and individually inspected before being installed. And here is the central point. Tesla patented this technology and then opened the patents to the entire world. Any company can read the design. But the design is not the machine. You know the secret, but you don't have the artificial intelligence system trained through thousands of tests. You don't have the quality process refined over years. And even if you did, you'd still need to integrate everything into a production line capable of manufacturing tens of thousands of units per month. Opening the patents is not generosity. It is a demonstration of distance. But no technology exists without real challenges. The first is production cost. The carbon sleeve technology is not cheap. Will Tesla be able to bring it to mainstream models, such as the Model 3 or the Model Y? Or will it remain confined to the premium end? The second is financial pressure. Tesla has faced redundancies and falling margins, whilst the price war with Chinese competitors intensifies. BYD, SAIC, and NIO are producing millions of cars at lower costs and expanding into international markets. In a price war, the best technology does not always win. The third is the dependence on Elon Musk. The controversy surrounding him, his divisive statements and promises not delivered on time affect consumer confidence in the brand. The fourth is charging infrastructure. As Tesla opens its supercharger network to other brands, that advantage becomes less exclusive. And range anxiety remains a significant psychological barrier. The fifth is autonomous driving. Tesla has been promising full self-driving for years. The technology has advanced but has not yet reached the promised level. That gap erodes credibility. And the competitors? Lucid Motors has impressive engineering. The Lucid Air surpasses the Model S in range, but it produces and sells few cars per year, without sufficient revenue to develop next-generation motors at scale. Rivian builds something different, pickup trucks and SUVs for the outdoor lifestyle, with solid design and financial backing. But in terms of pure motor technology, it still uses conventional architecture. Ford proved with the F-150 Lightning that Americans buy electric pickup trucks, but it relies on external suppliers and has cut production targets several times. GM has invested billions in the Ultium platform, but has suffered delays and has not created any technological moment comparable to what Tesla has just achieved. And then there is BYD, the name Tesla needs to watch most closely. It has overtaken Tesla in global sales, has a vertically integrated supply chain, manufactures its own batteries and chips, and is pushing aggressively into Europe, Latin America, and Southeast Asia. Its weakness: the brand and software ecosystem is not yet strong in the United States, and trade tariffs block its entry into the American market at scale. The central point is this: no rival threatens Tesla on all fronts simultaneously. Lucid has the engineering, but lacks scale. BYD has scale, but lacks brand strength in America. Ford and GM have brand strength, but lack both. Meanwhile, Tesla has all of this, and has now added a motor that nobody else can copy. The story goes beyond cars. This technology has potential applications in electric aviation, where the motor needs to be light and powerful enough to operate safely, precisely the characteristics of the Plaid. And in energy infrastructure, wind turbines, industrial pumps, large-scale storage systems. If Tesla can produce these motors in mass at progressively lower costs, it could become a supplier of electric motors for the entire clean economy. Tesla is no longer merely an electric vehicle company. It is becoming an energy and mobility platform for the 21st century. The history of technology has taught us that a technical advantage does not always decide who wins. Betamax was superior to VHS, but VHS won. The BlackBerry had a better keyboard than any touchscreen, but the iPhone changed everything. Nokia dominated for years and nearly vanished overnight. The electric vehicle market is still taking shape. Incentive policies can change. Battery prices are falling. Decisions on supply chains and tariffs can reshape the game in ways nobody anticipates. Tesla has done something extraordinary with this new motor, but the race is far from over. And anyone who claims to know with certainty who will win deserves skepticism. What do you think? Has Tesla truly closed the game with this new motor? Or can competitors, from Lucid to BYD, still spring surprises? Leave your thoughts in the comments, especially if you own an electric car or are thinking of buying one. If this video brought you something new about the electric vehicle revolution, give it a like to help this content reach more people. And if you want to keep following in-depth analyses like this one, subscribe to the channel. The race has already begun, and what happens next could be the most fascinating chapter this industry has ever written.